Next, let us see how to write an algorithm. Here already I have written one algorithm for swapping two numbers or two elements. See, I have used C language like syntax only. Only the thing I have done is here I wrote algorithm to show that okay, I'm writing an algorithm. It's not a program. Here, if I compare with the C program, here I have not written the data type of parameters. Yes, data types we don't decide at algorithm time. When we write a program, then we decide what data types are required. And here, even I don't have a temporary variable declaration. Declaration is not there. Directly it is used. It's understood. Unless you declare in the program, you cannot use it. But in algorithm, we don't bother about those minor things that are related to language. This is more like C. Now, if you want to write in a different way, you can say this as begin and this as end. Instead of lower brackets, you can also say begin and end. Next, you can use this symbol also for assignment. Actually, this is the assignment symbol that was used in some old languages like Pascal language. So you can use that one. Or else, you can use this symbol for showing that this value is stored in this one. So now it's up to you how you want to write it. I hope whatever I wrote you have understood it. So same way, whatever you write, I should be able to understand. At least you should be able to understand it. Or the people who are involved in the project should be able to understand it. Who are using it should be able to understand it. Right? So you can use any syntax. There is no fixed syntax for writing any algorithm. Let's see how to analyze an algorithm. What is the criteria on which we analyze an algorithm? So the criteria is, the first criteria is time. See, the algorithms are the procedures for solving problem. Whether you do it manually using pen and paper or you make a program and let your machines do it. Whatever the method may be, how much time it is taking. If the procedure is very lengthy and time consuming, or whether the procedure is very fast and quickly you can get the results. So that is one of the important criteria on which we have to analyze. If you are devising a procedure or an algorithm, then it should be time efficient. Means it must be faster. So after writing the algorithms, we analyze how much time it is taking. So that time, what we get is in the form of a function. We get a function, time function. We not get the watch time. Already I have shown you. You will get the function, time function. Now, next is space. As the algorithm is going to be converted into a program and it's going to run on the machine, then we need to know how much memory space it will consume. So that is the second criteria on which we will analyze an algorithm. So these are the two major criteria on which the algorithms are analyzed. And furthermore, if you have any other criteria, or any other factors you want to consider, you can consider them. Like, now, nowadays, every application is either internet-based, web-based, or say cloud-based. So, data transfer or network consumption is also an important criteria. How much data is going to be transferred? See, if the algorithm, or means if a procedure that you are writing, if it is unnecessary transferring larger size data, or it can be reduced or compressed, whatever it is. So that is one more important criteria, that is how much data transfer is done. And nowadays, most of the devices are handheld. Instead of PCs, we are using palm tops and laptops and tablets. Then power consumption is also a criteria. How much power it is consuming. And one more criteria is, if you are developing an algorithm for device drivers or system level programming, if you are developing something, some algorithm if you're writing, then you may also need to know how much CPU registers it is consuming. So CPU will also have some memory called as registers. How many registers it is consuming? That's also one of the worrying factor when you are designing an algorithm or writing a program finally. So these are few criteria I have listed, and it depends on your requirement, it depends on your project, right? What are the more criteria you need to analyze? Now let us see. I have taken one example to show you how we analyze an algorithm. So for analysis purpose, we need to know the time. So first we'll do time analysis. Then we'll do space analysis. Now time means how much time this will take. This is not the watch time. Then how to assume? Now we say that every statement in an algorithm takes 1 unit of time. Every simple statement in an algorithm takes 1 unit of time. If suppose the algorithm is calling another algorithm, it's using another procedure, then we have to analyze that also in detail. So simple means just statements, direct statements. It's not a nested statement, right? So single statement, each statement takes 1 unit of time. So here I assume it takes 1 unit of time, 1 unit of time, 1. So total time is 3. So the time function f of n is 3. Here we got the constant value because I have taken a very simple algorithm and the answer is 3. That is some constant value, right? 3 or 30, whatever it is constant value, fixed value we got. So that's the time function. It is not in terms of n, just we got a constant value. Now here, whatever the complexity in the statement may be, how lengthy the statement will be, we say that it takes 1 unit of time. Let us assume, instead of this statement, I have some statement saying x assign 5 into a plus 6 into b. If this is the statement written in an algorithm, then for this also we say it takes 1 unit of time. But really, if you see, when you convert into a program and finally when it gets converted into machine code, then how many statements it will have? For each multiplication, 2 statements. Then for addition, 1 statement. Then assignment, 1 statement. So total 4 statements will be there. But we don't want to go into that much detail. We don't want to see how it's going to get converted into machine code. But simply we analyze and say each statement takes 1 unit of time. Now suppose if you want to go into detail analysis like this, you can go into detail. You can imagine up to the level of the machine code that's going to be generated. It is just like, suppose you want to travel to your friend's house in a car. You don't have to think and you don't have to plan and analyze. Simply you can take a car or your bike, your vehicle, and you can just start and reach his place. Right? It's simple. If you want to land on Mars, then simply you cannot take a satellite, so simply you cannot take a rocket and launch it and reach there. It's not easy. So you have to analyze and design and make a complete plan so that your mission is successful. So that's it. Here you need to go into each and every minor detail, you have to take care of it. So it depends on your requirement. So if you want to analyze into greater detail, then do it. From subject point of view, we will be doing it at basic level, right? At a very shallow level, this brief analysis we will do, will not go into much detail. But much detailed analysis can also be done. Next is space analysis. What are the variables used here? For a space, I'll write down the variables. A is one parameter, B is also a parameter, and temp is the local variable used. So total, how many variables? 1, 2, and 3. So there are 3 variables used. So the space is constant again. It is just 3. I got the answer as 3. So again it is also constant. So usually we represent them as order of 1. Constant means order of 1. And that's also order of 1. means it is constant. 1 represents constant. If it is 3 also we write 1. If it is 3000 also we write 1, saying that it is constant, value is constant. So this how each statement is taken as 1 unit of time and each variable is taken as 1 word. So these are 3 words. Why we are saying words there, not bytes? We don't know. When we convert it to a program, it may be an integer type or float type or double type, that we don't know. So that's why we say it is taking words.